In lesson 4.2, we're looking at the definitions of 6 trigonometric functions, and then we're going to evaluate those and actually consider the unit circle. So to begin with, our 6 trig functions are these listed over here in the table: sine, cosine, tangent, cosecant, secant, and cotangent. And notice it says of theta. Now theta is back over here. It's this little angle that terminates here in the first quadrant that they've got marked. Okay, so to abbreviate these terms, we got sin, theta, but we still say the sine of theta is, and this is its definition, it is y divided by r. Now, as I look back here at this terminal side, there is a point on the terminal side, that xy, that ordered pair. Well, if I use the fact that this is a right triangle being formed, I know if this is a leg x and this is a leg y, to find r, we say x squared plus y squared equals r squared. And so then, down here at the bottom, we're going to solve for r. So r is equal to the square root of x squared plus y squared. So we're using that fact, and x and y, the ordered pair. So the sine of theta is defined as the y value divided by r, and the cosecant, notice its abbreviation, CSC, is the reciprocal of that, r over y. And then we have the cosine of the angle, which is x over r, and its reciprocal is secant, which is r over x. And then we have the tangent of the angle, which is y over x, and its reciprocal is the cotangent of theta, which is x over y. Now that's just our definition, so let's use those and consider a problem. Okay, so our problem here is we're given the point 5, 12 on the terminal side of angle theta, and we're asked to find the 6 trig functions. Okay, so let's see if we can do that. Okay, so to begin with, what we're going to need to do is figure out our value for r. Okay, and remember how that was defined. Now, r was the square root of x squared plus y squared. Okay, r equals the square root of x squared plus y squared. Well, in this case, our x is 5 and our y is 12. So if we plug those numbers into that, we've got r is equal to the square root of 5 squared plus 12 squared, which is actually 25 plus 144. So we're looking at the square root of 169. So that means our value of r is 13. So that's the length of that value in that triangle. So now let's go back and just plug into our definitions. So our definition for sine of theta is equal to the y value over r. I'll just write it down here. That's our definition. So I'm just plugging in. 12 is my y, r is the 13. And then the reciprocal of that was our cosecant. So while we're right here at that, we're just going to flip that answer, and our cosecant is 13 over 12. Then we have the cosine of theta, which was defined as x divided by r. So our x here is the 5, so we've got 5 over r is 13. And the reciprocal for cosine is secant. So we'll go ahead and jot that down. So that's going to be 13/5. And then we have the tangent. Let's look at tangent first before we look at the cotangent. So the tangent of theta is y over x, which is our 12 over 5. So that's our tangent. So that means the cotangent of theta, the reciprocal of that, is going to be 5 over 12. So that's the value for the 6 trig functions. Now, in the second question, it says, given a function, find the others. So if I'm told the secant is the square root of 5 divided by 2, let's go back to our definition of secant. Our value for secant is defined as being the reciprocal of cosine. So that means that is r divided by x. So going back to our little formula up here at the top of the page, we're going to plug in that r equals square root of x squared plus y squared and see if we can figure out what y is. We know what r and x are because that was the square root of 5 divided by 2. So I know r is square root of 5 and x is 2. So let's plug that in. R is the square root of 5 and x is 2. And we're going to try to figure out what y is. Oh, that's underneath this radical. So I'm going to clean this up since I've got both radicals on both sides by squaring both sides. So when I do that, I end up with 5 equals 2 squared, which is 4, plus y squared. And then subtracting 4 from both sides, that gives me 1 equals y squared. And then when I take the square root of both sides, my value for y could be either a positive 1 or a negative 1. It's because the square root of 1, the principal root is 1, but even if I had a negative 1 and squared it, that would give me 1 as a possible answer. So, and they didn't tell us in the problem what quadrant this angle terminated in. That would help us decide which one of those to use. So I'm just going to leave it like that, plus or minus 1. So our value for the tangent of theta is going to be, going back to our definition, tangent of theta, gracious, is y over x so that's going to be plus or minus 1 over 2. And we choose one of those depending on what quadrant we're looking at, but we really don't know right now. And the cosine of theta, going back to our definitions, cosine and secants are reciprocals of each other. So we're just going to flip the secant one. So that's going to be 2 over the square root of 5. Now, in mathematics, it's not considered a very good form to leave a radical in the denominator. So to take care of that, we're going to rationalize that denominator by multiplying both the numerator and denominator by the square root of 5. You can have radicals and answers. They're just not considered in best form if it's in the denominator. So multiplying across, we get 2 square root of 5. And the square root of 5 times square root of 5, square root of 25, which is just plain old 5. So that's going to be our cosine of the angle. Okay. Let's see. I can exit that. And move on. And then for our last one, we've got the circle that's centered at the origin and has a radius of 1 is called the unit circle. That's really important in trig. The circle that has a radius of 1 unit. Because if you'll notice here up in the drawing that this terminal side here, with it being 1, that would be the hypotenuse of these right triangles that we're going to be looking at. So, but it makes our computations a lot easier because if I'm looking for cosine of an angle, the cosine is just going to be x because it's x over r, and r is just 1. And the sine of an angle is going to be just y because that's y over 1. And the tangent is still y over x. So to figure out the cosine of this angle, let's see if I can get back up here on the drawing. So the cosine of 0 degrees is just the x value at 0 degrees. So the cosine there is just going to be 1. That's my answer. That's the x value of this ordered pair. And at 0 degrees, that's the y value of that ordered pair. So that's just going to be 0. That's pretty easy, wasn't it? And then if I have this unit circle that intersects exactly at that point. So the key here is they're telling me it's a unit circle. So that tells me r is equal to 1. Well, if that's the case, this is x and this is y. The sine is just y. So the sine of theta is 0.96. And the cosecant is the reciprocal of sine. So that would be 1 divided by 0.96. And let's see what that number is. Oh, gracious. And that would be about, we'll round it off a couple of places, 1.04. So that's our two answers for the last part of that. I hope this has been helpful.